Well, your favorite when an equation or something that you've been taught is slightly off or may not be the full truth or the whole truth. So we have been studying gases under the premise of the ideal gas law when gases behave in ideal situations. Now, for the most part, the ways that we've discussed gases, they do behave in ideal nature. Now, those conditions are usually under low pressure and relatively high temperatures. So basically, and high temperatures meaning like 0 Kelvin, or I mean those are that is a high temperature if you think about 273 Kelvin, right? So what we're going to do now is look at kind of how gases deviate from the behavior of the ideal gas law when we change some of those conditions, when we change the pressure, when we look at different temperatures. Okay, so when you think of a gas, its behavior can actually change drastically just depending on the temperature it has and obviously the pressure. So you've got an example of a gas here, and depending on its temperature, it has a very different type of behavior depending on what temperature it is, from 200 to 1,000 Kelvin. So why does it deviate? What are some of the reasons? Well, when we assume ideal behavior, the kinetic molecular model assumes that the volume of the actual gas molecules, the space that the matter itself takes up, is very negligible. And we also assume that there is no attractive force between gas molecules. But this behavior breaks down at high pressure and or at low temperatures. So if you crayon those particles closer together under high pressure, the actual volume of the gas starts to make a difference, starts to impact the actual behavior of a gas. But we can take the ideal gas equation and adjust it to basically include the deviations from ideal behavior, so under high pressure or under very low temperatures. And ultimately, it really just makes the ideal gas equation more complicated because it's a more complicated story that's being told under high pressure or at low temperature. So we need more variables. We need to keep track of more and calculate more with it. So this corrected ideal gas equation is known as the van der Waals equation. And how it looks is this one here at the top. And basically you have some pieces, so under high pressure, under low volume kind of stuff, it's gonna be modified. And so you see that the pressure has this additional piece being added to it, and you have the volume having an additional piece subtracted from it. And A and B are other variables or van der Waals constants that we would include in the equation, and they're specific to specific gases, gas molecules. And so obviously you would need access to a table or that information to properly calculate, under extreme conditions, or what would the actual volume be of a gas or the pressure of a gas be under certain conditions. So we are going to apply this in class tomorrow, or you will. I obviously will not be there, but and this is the last section of Chapter 10, which leads us to just spending time reviewing and preparing for the big test next Thursday. So I will see you at school tomorrow.